Welcome to MzansiNumerics. We're going to go through roughly all we need to know about vertical projectile motion. So these are the different problem types that you will come across when you're dealing with vertical projectile motion. Before, there are going to be 5 videos. The first video is going to just be an introduction, which is this video. And then the second video will be type 1 and problems relating to type 1. And then so on until type 5. So before I start to introduce these problem types, let's start with the definitions that you need to know when you're dealing with vertical projectile motion. So there are 2 definitions which are prominent. So the first definition is projectile, and then the second definition is freeform. So I chose to define these definitions together because they are similar, but at the same time you have to know their differences. This one is about an object, and then this one is about the motion of an object. So, and this definition, both of them have one keyword, and then that keyword is gravitational force only. So that's the keyword, and also this one has the keyword of gravitational force only. So how do we define projectile? It's an object that has been given initial velocity and moves under the influence of gravitational force only. So let's put it in an example. Let's say you are playing with a ball. You project a ball vertically upwards and then it comes back to the same location. Let's say you throw a ball up, it comes back to your hand. So now when you throw this ball has initial velocity which is greater than 0 because we have projected it upwards. So when it moves, it's the only force acting upon it which is making it to come back again is gravitational force. So if it is only gravitational force that is acting on that ball, it means that that ball is in free fall. It's in free fall, or it's a projectile. So let's define free fall now. Free fall is a motion in which the only force acting on an object is gravitational force. So this one is the motion in which the only force acting on an object is gravitational. So using the same situation, if you throw a ball vertically upwards and then it comes back to the ground, so when you project it up, it's a projectile. But if it moves under the influence of gravitational force only, we say that motion in which is moving in under the influence of gravitational force only, it's called free fall. Free fall is a motion, but projectile is the object that is moving under free fall. That's why when other books, when they define projectile, they say it's an object that has been given initial velocity and moves under free fall, because this part of gravitational force only is included in free fall, because free fall is the motion in which the only force acting on an object is gravitational force. So what do they mean when they say the only force acting on an object is gravitational force? So in vertical projectile motion, we deal on the movement of the ball in the vertical plane. So it's either the ball is going up or it's either the ball is going down. So when they say that this ball, when you throw it up, the only force acting upon it is gravitational, it means that at any point of that motion, if you draw a free body diagram of all the forces acting on that ball, the force will be Fg. The only force, or the free body diagram, will consist of Fg only. And then we know the Fg equals to what? Equals to 9.8 meters per second. So when the only force is acting on the object is Fg, it means that the object will accelerate in the direction of Fg according to what? To Newton's second law, because Newton's second law says what? When a force acts on an object, the object will accelerate in the direction of the force, meaning that at each and every position in which you throw that ball upwards, it will be accelerating downwards. Because of what? Because acceleration due to gravity. uh, if maybe you throw the ball with velocity of 5, because it's accelerating downwards, gravitational acceleration, it's always downwards. Because what? Because it's the force that the earth exerts on an object and pulls each and every object above its surface to the center of the earth. So if you throw a ball upwards with 5 meters per second velocity, it will accelerate downwards because the velocity will increase to 3, 2, 1, and then it reach a maximum height where the velocity is 0. And then when it reaches 0, it will come back again, 1, 2, accelerating as it is going down. It will accelerate as it is going down until when it reaches a maximum velocity here, when it is about to reach the ground. So what do we see here? Even when the object is thrown upwards, gravity is still acting. That's why it is decelerating or accelerating downwards at each and every point of this motion. So that's what we mean when they say that the only force acting on an object in projectile or in vertical projectile is gravitational force only. So just know that each and every time you are given a scenario under vertical projectile, you have an unknown value which is always known, and it is 9 meters per second. So here it's per second squared because it's acceleration, and then this it's always downwards because it's always pointing the earth. So this is the introduction to vertical projectile motion, where we learn this definition. So in the next videos, we are going to go through these problem types. So problem type 1 is when a projectile is dropped from a certain height. So if a projectile is dropped from a certain height, and let's take for example a ball. You are on a building, you mistakenly drop your phone or a ball or a stone, and then that stone will accelerate downwards. So this is the situation number 1 that we are going to learn about, which is problem type 1. We are going to also deal with certain question papers on this problem, and then we firm understand the type 1. And this one, and the type 1, there's also two situations. The other situation is not when you drop it, it's when you throw something vertically downwards. The line of motion will also be the same as in it is dropped, because they will be all going down from the top of the building to the bottom of the building. Then now the second one is when a ball is thrown vertically upwards. So if a ball is thrown vertically upwards and then comes back to the same height, let's say for example you are playing with a ball, then when you are playing with the ball, you throw it upwards, it comes back to the same location, comes back to your hand. So we are going to deal with this one of problem type 2. So to understand, so the final position is equal to the initial position. So the displacement here is 0, but we are going to explain it when we get to it. Now problem type 3 is a projectile projected vertically upwards and which falls back below the original. So let's say you are playing with the ball on the top of a building. Then when you are playing with that ball on the top of the building, you throw it up, and then when it comes back, you fail to catch it, and then it comes back below the original the original height, which means that here it's gonna come back to the original. You fail to catch it and comes back here. So this is the situation we are also gonna deal with. Note that this portion here of motion here, let me circle it, is similar to this portion of motion here. So you can deal with this section of motion the same way you deal with this one. So let's go to type 4. Type 4, it's when it's a bouncing ball. So there are arcs, the ball bounces and comes back. This is the time between this contact time, this time that the ball spins on the ground, and then it goes back. is similar to this one, because let's say maybe you throw a ball up, it lands on your hand, bounces on your hand, goes back again, goes back again. So until that's not that the first arc is greater than the second, and if the second is greater than the third, because when it hits the ground, it loses some kinetic energy and doesn't go back to the same height until it comes down. And then the third one we are gonna deal with is a hot air balloon. A hot air balloon, and we are not dealing with the hot air balloon as a projectile, because the hot air balloon is not a projectile. We are gonna deal with a ball that is thrown from a hot air balloon. Why is the hot air balloon not a projectile? It's because in the hot air balloon there is another force which is propelling the balloon to go up, which is the force of the engine, which goes against the force of the gravity to pull up the hot air balloon. So it's not a projectile, because what's a projectile? It's when gravitational force only is acting on an object. That's why we deal with a ball that has been thrown up or thrown up down from the hot air balloon. So we are going to look at how the velocity of the hot air balloon temper or change the velocity which you throw the ball in. So this one is a bit interesting and a bit complex, but we are going to deal with it when we get to it. So this is the introduction of the video. Thank you for watching.